All right, for question one, completing that function table, what we are given right there is with substitution. So we're gonna bring that on over when I compare that to the function itself. And let's go ahead and evaluate that. -3 squared with parentheses is is positive 9. And a -3 gives me another positive 9. 9 plus 9 is 18, and 18 plus 2 gives me a value of 20. That means x was representing as -3, and when I substitute that in for the f of x, again, -3. Letter B, x is representing as 4. So I replace 4 wherever I see x, and then I go ahead and evaluate that. 4 squared is 16, minus 4 plus 2. So 16 minus 4 is 12, and 12 plus 2 is got a value of 14. Last one, they specifically tell you x is -2. So wherever you see x, replaces -2. And as we get ready to evaluate this, watch your negatives. -2 squared is 4. 2 negatives make a positive. And plus 2. So 4 plus 2 is 6. 6 plus 2 is 8. And I just caught myself right up here. That should have stayed a positive 3. I accidentally wrote a 9 there. 9 plus 3 is 12, and 12 plus 2 is 14. On number 2, like we've been doing, how are you moving from -42 to -39? I try one of my 2 tricks. I go ahead and subtract the second term from the first term, go to decimals, plug it in, it should give you a value of 3. If this is arithmetic, then adding a 3 from one term to the next should give me the sequence. And it does, okay? A plus 3 keeps giving me that sequence. So that means it's arithmetic. That means we have a common difference of 3. And the next 2 terms then are -30 and -27. Keep adding 3. Now, on letter B, this one I'm going to check to be geometric because I can tell I am multiplying by -3 to go from one term to the next. And the way I can find that magic number is the second term divided by the first term. So go ahead and multiply by -3, and that changes my signs and gives me the next term. So it's geometric. That means we have a common ratio. And then let's go ahead and multiply. -54 times -3 gives me a positive 162. 162 times -3 gives me a -486. Number 3, go ahead and take 2 and 10 and make it geometric and then make it arithmetic. So if it's going to be geometric, then I have to have a common ratio, which is calculated by second term divided by first term. And that means we're going to multiply by 5. So 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. And 250 times 5 gives me 1,250. If it's arithmetic, then I should be taking the second term minus the first term to get what we call our common difference, which in this case would be 8. 2 plus 8 is 10. 10 plus 8 is 18. 18 plus 8 is 26. 26 plus 8 is 34. The first term of the sequence for the geometric one was 2. The third term was 50. Remember, this was the first term, second term, and then we created terms 3, 4, and 5. For letter B, okay? The next 3 terms of the geometric sequence, to be geometric, I have to have a common ratio, which is, in this case, second term divided by the first term of 1/2. 20 over 40 becomes 1/2. So 20 times 1/2 is 10. 10 times 1/2 is 5. 5 times 1/2 is 5/2. To be arithmetic, you calculate the common difference. So in this case, second term minus the first term is a negative, no, that was right, -20. So we're adding a -20 each time. 20 plus negative 20 is 0. 0 plus negative 20 is negative 20. Negative 40. The third term focuses on the geometric sequence. The geometric sequence, the third term was 10. We created terms 3, 4, and 5. And the fifth term was 5 halves.